You know, we all live this incredibly digital life, but have you ever stopped to think about what's actually holding it all together? Today, we're going to pull back the curtain on IT infrastructure maintenance. It's the silent, absolutely crucial work that keeps our digital world from, well, falling apart.
Think about it. Every single app you use, every website you visit, it all relies on this incredibly complex web of servers, networks, and databases. And this isn't stuff that gets replaced every year. We're talking about infrastructure that's often used for years, sometimes even decades. And just like anything built to last, it needs constant care to stay healthy.
And that really is the big question, isn't it? When this invisible world starts to fail, our digital life just grinds to a halt. So how do we stop that from happening? Well, we need what you might call a proactive doctor, someone who doesn't just wait around to treat illnesses, but works tirelessly to prevent them from ever happening in the first place.
So yeah, let's start there. When the system gets sick. You see, a new project might get built in a few months, sure, but its operational life, that's a marathon, not a sprint. Making sure it stays healthy over that entire life cycle is the real challenge. It's a continuous, never-ending process of care.
So how do we actually provide this care? Well, turns out there isn't just one way to do it. The best way to think about it is like different schools of thought in medicine. We're going to look at three major frameworks that organizations use to keep their systems healthy, and each one has a totally different focus.
Okay, this table breaks down the three big ones, and it's really helpful to understand why each one came to be. First up, you've got COBIT. It's all about governance and control. It actually grew out of financial auditing, making sure IT goals line up with the business goals. Think of it like the hospital's board of directors, setting the high-level rules and policies. Then there's ITIL, which is probably the most common one. It came from the UK government trying to standardize IT. It's like a super detailed medical procedures manual, a reliable, repeatable process for every little thing, all designed to reduce chaos. And finally, you have DevOps, which is a whole different way of thinking. It's all about culture and speed. This is your integrated care team, where doctors, surgeons, and nurses all work together seamlessly, a modern answer to the slow, old model of just throwing work over the wall.
All right, so regardless of the philosophy you choose, every good doctor starts in the same place, checking the patient's vital signs. For IT infrastructure, this means real-time monitoring, keeping a constant eye on the system's pulse.
So what are we really looking for? Well, monitoring is all about catching problems before they turn into full-blown catastrophes. We're talking about those little warning signs of upcoming failures, like a disk that's almost full, a CPU that's working way too hard, or a network that's starting to get clogged up. It's the system's early warning signal.
And this image right here, this shows you exactly what that looks like. This is a Nagios dashboard. You can literally think of it as the heart rate monitor in an ICU. It gives system managers this live, at-a-glance overview of the entire infrastructure. And the best part is, alarms are set up to go off the second a critical level is hit, so they can jump in and fix things before you or I ever even noticed there was a problem.
Now you might be wondering, how in the world do you gather all those vitals from so many different pieces of equipment? Well, one of the key tools for that is something called SNMP, or Simple Network Management Protocol. It's basically a universal language that lets a central system talk to pretty much everything on the network: servers, routers, printers, you name it.
And the way it works is, honestly, just beautiful in its simplicity. You've got the central management server, the NMS, and it regularly polls each device, asking for specific data points. The agent on the device then reports back with those stats. But here's the really clever part. If a critical value is crossed, let's say network load suddenly hits 80%, the agent doesn't wait to be asked. It sends an immediate alarm, called a trap, straight to the manager. It's brilliant.
Checking vitals is absolutely essential, for sure. But sometimes a problem is way more complex. And to make a proper diagnosis, a doctor needs to look at the patient's entire medical history. For our systems, that history is all recorded in the log files.
This slide highlights a super important distinction. Monitoring is all about the now. It's the real-time alarm that screams, hey, something is breaking right now. Logging, on the other hand, is about the past. It's the detective work you do after the fact to figure out exactly why it broke.
And this is what that history looks like. I know, it might just seem like a crazy wall of text, but trust me, this log file is an absolute goldmine of information. Almost every piece of infrastructure generates these logs, creating this detailed, time-stamped record of every single thing that happens. When you need to solve a really tricky problem, the clues are almost always hiding right here.
So why would anyone sift through these massive files? It really comes down to four critical jobs.
First, you need them for compliance, to prove you're following security rules. You definitely need them for troubleshooting, to find the root cause of a glitch. And when something really bad happens, they're essential for digital forensics and incident response, to piece together exactly what happened during a security breach.
And let me give you a perfect case study of this in action. A team was pulling their hair out trying to figure out why a web server was so sluggish. After digging through the logs, they found this. The application was trying to open a file that didn't even exist, thousands and thousands of times a day. They removed that one bad line of code, and boom, performance instantly improved. That's the power of reading the patient's history.
Okay, so we've checked the vitals and we've read the history. But a truly great doctor doesn't just react to sickness, right? They create a long-term wellness plan to keep the patient healthy for years to come. In the world of IT, we call this capacity management.
The goal here is actually pretty simple. Make sure you always have enough processing power, storage, and network bandwidth to meet whatever demands are thrown at you, both now and in the future. It's all about planning ahead so you're not stuck making last-minute emergency hardware purchases.
So how do you actually create this plan? Well, it's a mix of looking at the past, the present, and the future. You analyze monitoring trends like seeing disk usage grow by 5% a month to predict future needs. You have to look at business plans because a huge new marketing campaign probably means you're going to need more server power. And of course, you keep an eye on technology developments so you can plan for upgrades when better, faster hardware becomes available.
And that really brings us right to the core idea. Great infrastructure maintenance isn't a one-time fix. It is a continuous, proactive cycle of monitoring, analyzing, and planning. It's a true commitment to the long-term health of the system.
This quote right here, it perfectly captures the modern DevOps philosophy. The responsibility for the system's health doesn't just end when it's built. The team that creates it is the same team that runs it, that cares for it, and that fixes it when it breaks. The builders are the doctors, and they are on call for the entire life of the patient.
So ultimately, the big takeaway is this. The invisible infrastructure that powers our entire world requires constant, unending vigilance. It's a patient that never ever sleeps. And because our digital lives depend on it, the proactive doctor must always be in.